Students who are preparing for senior secondary board examination, JEE Mains, NEET, these videos are made for them. I will upload almost every day a new videos for those students who has chemistry one of the major subjects. So you are requested to please keep a watch on my YouTube site and you will get the new topics almost every day. I will discuss the topics free radical halogenation of alkane, mainly for chlorine and bromine. Today we will discuss free radical halogenation of alkane. Chlorination. How the free radical of chlorine is formed? When a chlorine molecule is exposed to sunlight, then it dissociated homolytically into two chlorine radical with 7 electrons each. This chlorine radical is very much reactive. It attacks one methane molecule, abstract hydrogen formate, forming one HCl molecule and one methyl radical. This methyl radical will react with the next chlorine radical to form a chloromethane. So the first step, it is CH4 plus Cl2, it will be CH3Cl plus HCl. Now homolytic dissociation means chlorine molecule under sunlight, of course diffused, not direct. Direct it is very much explosive. Two chlorine radical with 7 electrons each. This way the reaction with methanes begin. So this is the chain initiation step. When a chlorine molecule is dissociated homolytically to form two chlorine radicals. Thereafter, continuation of the chain forming monochloromethane, dichloromethane, trichloromethane and so on. This part of the chain is called propagation. At the end, either there will be excess of chlorine radicals or maybe excess of methyl radical. Whatever may be, by combining with two chlorine radical, chlorine gas will form, or two methyl radical will give you ethane. So at the end of the chain, you will get either little bit of chlorine or little bit of ethane. So total reaction proceeds through 3 steps: chain initiation, chain propagation and chain termination. Take the example with propane, CH3, CH2, CH3. Now propane has 1 degree as well as 2 degree hydrogen. 1 degree is 3 plus C6, 2 degree 2. Ratio of halogenation in propane will be 1:3.8. That means 6 hydrogen will be replaced to give you 6 products, and 2 degree will give you 2 into 3.8, 7.6. Altogether you will get 13.6 number of products. So 6 number of product will be 1 chloropropane, and for 2 degree or 2 chloropropane it will be 7.6. Take the cases with propane again, but the substituting molecule is bromine. For bromination, the ratio 1 degree is to 2 degrees to 3 degrees should be 1 is to 80 into 1600. So, in this propan molecule, how many 1 degree hydrogen is there? 3 plus 3, 6. And 2 degree, 2. And no 3 degree. So, 1 degree H means 6 into 1, 6. 2 degree hydrogen means 2 into 80, 160. So, altogether it will be 166 numbers of molecules of bromine. Now, see the difference. Why this happens? Because bromine is very specific substituting group, I mean molecule. Whereas fluorine is non-specific. It reacts very fast. It is exothermic nature and substituted almost all possible hydrogen there. But bromine will select fast. Most stable that is 2 degree hydrogen. Then it will go for 1 degree and it is endothermic. It requires it. That is the reason you get the ratio different way. So, in conclusion, you can say substitution is fluorine, non-specific, very reactive, exothermic. Substitution is bromine, very specific, looking for stable hydrogen and endothermic. Consider the next molecule, that is 2-methyl propane. Here 3, 3, 3, 9 1 degree hydrogen and 1 3 degree of tertiary hydrogen. As per the ratio 1 is to 80 is to 1600, number of hydrogen 1 degree hydrogen will be substituted is 9 total number, whereas 3 degree hydrogen only 1, it will be 1600. So altogether you are getting 1609 types of molecules, numbers of molecules, in which 1 degree hydrogen is 9 and 3 degree or tertiary hydrogen is 1. So this way you can understand the nature of propane, nature of halogens will give you different outcome. Direct fluorination and direct iodination is not possible. Why? Because direct fluorination will produce lot of hits. It is very exothermic and explosive too, and you cannot control the reaction. Similarly, in case of iodination, the reaction will be reversible, so you cannot reach the end point. That is why these two elements are not directly substituted, rather they are substituted by the one method, Finkelstein for iodine and Schwartz reaction for fluorine. Here is the reaction: CH3Br plus sodium iodide, CH3I plus NaBr, CH3I plus AgF, CH3A plus AgI. Only thing is that follow the principle. This is weaker than sodium, electropositive. This is stronger than iodine, electronegative. So in this reaction, weak will be attracted by the weak, CH3I, and strong will attract the strong. Similarly here is strong, will go for fluorine. Fluorine is stronger than iodine. So we understand fluorination and iodination is done by an indirect method.